This is an entire computer vision project written in Python entirely on the phone. Hi, welcome to this new video. My name is Sergio, I'm a computer vision developer and consultant, and I help companies, freelancers and students to easily and efficiently build computer vision projects. Today, we will be building a computer vision project from scratch by using the phone. So I want to show that everything is possible even with just a phone if you have access to the internet. And we'll be building a simple project where we take a picture, we detect the objects that are in the picture, so if there are people, if there are computers or other things, and then this program is going to automatically make a report of the picture. So it's going to say something like this. In this picture there are 2 laptops, 3 people, and so on, and then we're going to save a text file describing the picture. We're going to do everything right now, so let's go. A very quick note about the phone: it doesn't really matter which phone you have as long as you have a browser and access to the internet. So whether you have Android, iPhone, and then you have whatever browser you have, that's fine, and you're ready to go. And now let's follow everything right here. What is happening? I'm going to show everything in real time. First of all, we go to the browser. I'm going to open a new tab, and we're going to access Google Colab. Google Colab is a free service offered by Google where we can write our Python code online, and it's colab.research.google.com. so you need to type colab.research.google.com and then let's press enter. Here we can choose now to either if you have older notebooks, we can use those ones. So if you had already project that you did before, you can see your own projects even if you wrote them with the computer, or we can start our new project. So I'm going to new notebook. Anyway, to access this, you need to have a Google account. If you have a Gmail, you have for sure a Google account. If you don't have one, you can make it, and it's absolutely for free. It's free, the account, and it's free to use the Google Colab service that I am using right now. So it takes a few seconds to run the notebook, so let's wait. This is what a notebook looks like. It's an empty page where we have a cell. You can know the cell by the play button that you see right there, because that's where we can execute the Python code. So it looks something like this. I print, and then I'm just executing like the most basic Python code ever, like hello. And then let's close this one, and now I'm going to print this to run it, and you will see now the cell which is going to run. At the first run, it takes a while just to run, because first of all it's allocating a memory, so it's giving you a space. You see RAM and disk appeared, and now later it will be everything much faster. So we see the code hello. We can close this. We can put as many cells as we want. We have on the top left, we have this plus sign, and we can add the cells right here. Plus, we can choose to put the files inside the Google Colab memory by going on this menu on the top left. We can access different settings of this notebook. We will not go into the details of everything because you don't need that, and it will just be more confusing, but we just go on show file browser, which is the third option from the top. Show file browser. Here are the files that we have at the moment. So I didn't put anything, so there is nothing except some sample data which was there by default. But we can load our own files. So we see the icon, which is an icon for upload. We click that one, the first icon. We can either upload file from our camera. It means that we can take a picture or a video in real time and put them on the Colab, or we can choose to upload the files from our gallery. So I'm not going to take a picture. You can do that if you want. I'm going to use the gallery, and I have a few pictures right here. So let's load, in my case, the first one. I took this picture on purpose with the office because there are many elements that we can detect. So there are people, there are a few laptops, and there are also other objects that we will be able to detect. Now that the picture is loaded, we can see the picture right here. So we see pixels, voxels, that's the name of the picture. It's quite long, so I'm going first of all to rename this name because later I will need to load this picture and I want a very simple name. So I'm going to click on the three dots so that we can access the settings of the picture, and then I'm going to click on rename file, and I will just call this office.jpg, and that's all. So I'm now going to close this tab right here, and let's now write our code. Plus, we'll start by importing the Opencv library, which is the computer vision library that we are going to use to do all the processing and displaying the image. So we import CV2, which by the way is already installed. So that's the great thing, that Google Colab has most of the libraries already installed and we don't have to do much. Import CV2. By the way, it's important that you change the keyboard settings because there is the autocomplete function, and it's very painful when you are writing code to have autocomplete function. So at least on Android there is this settings icon that you can click, and you can just go, first of all, text correction, you need to disable autocorrection. So you see corrections is autocorrection, just disable that because it makes things very hard with the autocorrection when you're writing code. Then another thing, auto capitalization, you need to disable that because we don't want always the first letter capitalized, but we want everything lowercase, at least when we're writing code. So these two options that are usually on every phone by default must be disabled to make our life easier. Otherwise, I tried with them, enable it was a big pain. So just disable them. So we have imported CV2. Let's now load the image that we have right there. EMG equals cv2 dot imread, and then here we need to type the path of the image. I have office.jpg. If you have your own image, you need to type the title of your own image. And now let's run this cell to see if everything. So now we're running this code and we see that we didn't get any error. It means that everything was executed correctly. Of course, we don't see any output because we didn't add the output, but we can do that right now. So we want to show this image that we loaded. To show an image on Google Colab, we also need to import the library to show an image. So we have a patch which is from Google.colab colab.patches import cv2 underscore imshow. Now let's test this one. cv2 underscore imshow emg. And I'm very slow writing with the phone. I'm not used to write much with the phone. So probably for you it should be much faster than me if you use a lot the phone. This is the code. Let's now run this. And if everything is correctly, we should just see the image. So there is nothing extraordinary about this. And we see the image. So the first step is achieved. Now let's go to the core, to the most exciting thing. Let's detect the objects. Let's add another cell. So this one is going to be about object detection. There are many ways to detect the objects. For this one, I'm going to load a library that I have from my GitHub that I created before to make things very simple and fast. And let's do this. Let's install first of all the object detection. Git clone https :// then github.com/pysource7 and then simple detection. Simple detection. And after this, let's now run this one. So this is going to install the object detection library. And we have that. That was actually very fast. Now we can create our code to load this one. That we install the simple detection, we are going to detect the objects in this picture. We're going to use a pre-trained deep learning model which is able to detect 80 different categories of the most common objects. Among these there are like people, laptops, pen, book, different animals, car, different vehicles. So all 80 very common category. We'll be able to detect them and surround them with a box in this image. Let's do that. So here we do object detection. Let's add just a comment. This object detection is happening here. Object detection is happening right here. Now let's we install the simple detection from PySource. We're going now to import that so that we can use it from simple detection dot object detection import. Now the O must be capital letter, in this case object, and now the D uppercase detection. And now that we have this, we're also going to load this. So let's create OD, which is just a very short name for, say, object detection. We're going to load now the object detection so that later we can use it. OD equals, you can call this anyway, whatever you want. I'm just saying OD. You can put the name you prefer. Object detection, but this must be exactly as you see right here. Object detection. Then we open and we close the parentheses. Now we're going to run this cell to make sure that everything is working correctly. So you will see downloading DNN model. So this is downloading the model, the deep learning model who can detect the objects. And after this, you will be ready to use this. And we didn't get any error. So if you don't get any error, we are doing everything correctly. And now let's move on with the next steps. We loaded the picture, we showed the picture, we installed the object detection model. Now what do we want to do? We want to do one of the cores of this program, detecting the objects. Let's do that. How do we detect the objects? We can use the function OD. So from object detection we use detect, and we want to detect where? On EMG. We want to detect the objects on EMG. So EMG is this one. So we loaded the image. You see the first cell EMG equals CV2 imread. So that's the image that we have. Now on that image we're going to detect the objects. In exchange, this is going to give us three things. When we use object detection, we need the class ID. Class ID will say what object is that one. And we will see later how to convert the class ID into name. So if it's 0, let's say it's a person. If it's 1, it's a car. If it's 2, it's a bicycle, something like that. So class IDs. Second, the score. So how confident is the deep learning model about the detection? So this is a car and I'm sure about it 80%, for example. So that's the score. So scores, and then bounding boxes, because of course we also want the surrounding position. So we know that there is an object, but where is this object located? So we get the coordinates of the bounding boxes. B boxes, and then equals. And now let's go to a new line. Now let's print something of this. Let's say, for example, let's print class ID, print class IDs, and let's see what we get. Let's run this one. So it should be very fast. It's only detecting objects on an image, and this is what we have. We have an array with different numbers inside. This means that we have different objects. On each object there is a class ID associated. Now normally what we should do is to loop through everything, so that for the first object we know first object is ID 63. Then where is that object located? So let's do that. And also later we will see what objects are they. So let's do for class ID, score, and then a box in. Now we're looping together through the three different arrays, because we have a class ID associated to a score, to a box, so we have the same elements on all of them. So we loop through all of them together. So zip of class IDs, scores, then bounding boxes. Then let's close this one, colon, and let's now go down. No, I don't see the tab space here. Like usually we need to indent the code, so we will tab, but we can use 4 spaces. 1, 2, 3, 4. We can use on the phone. Let's close this output. We don't need that. Oh, I'm messing a bit with this. Okay. We can use 4 spaces. 1, 2, 3, 4. Now we can let's say, for example, let's get this the box, which is the most important thing right now. And later we will get also the class ID. Box has the coordinates, so let's get the coordinates from the box. We have x, y, width, and height. All are inside the box, equals box. Okay. And 1, 2, 3, 4. Let's, for example, print them. If we print, let's print x and y, or we can print box. It doesn't matter because we don't need this. I'm just showing you what this box does. So we're looping through each object, so each line is a different object. So the first line is 850, 472, 297, 156. The first number is the x position. The second number is y. So the first point is x and y. 850, 472 is the top left point. Then we have 297 is the width. So we have the width, and 156 is the height. With only this information, we can easily now display the bounding box surrounding each object. So let's do that. We do cv2. I forgot. I need to give 4 spaces. 1, 2, 3, 4. cv2 dot rectangle. Then let's open parentheses. Where do we want to draw the rectangle? We want to draw this, of course, on EMG. So we're going to use the same image always that we loaded before. To draw a rectangle, we need 2 points. We need the top left point, which is x and y. So top left, we have coordinate x and y. X, y. Let's close this one. Then the top left, right bottom. Right bottom will be the x plus the width. So we have x plus, where is the plus? Okay, plus width and then y plus height. y plus height. And let's now give a color to this rectangle. We're going to use the same color for all the objects. Later we can improve this. So to give a color in OpenCV, we have 3 colors. So the mixture of these 3 primary colors, the blue, the green, and the red, is giving us new colors, basically. Each color goes from 0 to 255. So we put the maximum of the blue, which is the first color, 0 of green, and 0 of red. And we close this. And then now we can also choose the thickness of the rectangle. Let's make it 2 or 3. Let's make it 3 pixels so that it's well visible. And now let's close this one. With this, we are already drawing everything that we need. But now we also need to display the image on the screen, of course. Otherwise, we are drawing the rectangle and we don't see anything. So CV2, let's now display, after we do everything, let's display the image on the screen. CV2.imshow EMG, and let's close this one. Probably that's all we need. Let's run this one. So this is the moment of the truth. Is the object detection going to work? Well, you will see the proof. If it's working, we will see the bounding box surrounding the objects. We have them, so I don't have to tell you that because you can see the object detection is working. What can we do right now? We can load the categories, and so we have the class IDs, and from class IDs we get the ID. We saw, okay, let's print now the ID. So it will make sense what I say if we see it. So if we print class ID, let's run this one. We have a few, okay, I saw something that it's interesting. We'll check that later. We see double bounding boxes right now. So I was saying, if we check the IDs, they are associated to a name. So we can also load the name. We have the names, and we have classes that are on od.classes. So if we print od object detection dot classes and we run this one, od.classes, we have an array where we have 80 elements. We have 80 different names. So first is person, second is bicycle, third is car, motorbike, and so on. So when the ID is 0, we take the first element from the classes array. So it means that 0 corresponds to person. If we had 1, it will be bicycle. If we had 2, it will be car. So the ID is associated to this array, and easily we get the class name that we want. Now, what is happening here is that we are drawing on, because we see multiple boxes each time. So each time we draw on the image, we are overwriting what was done before. And to solve this problem, we should run the cell where we load the image always before running the detection. So I could probably just import this one. Okay, I don't see the copy. I see only paste, which is giving me trouble. Okay, I will have an easier solution. So I'm going to run this one. So now we have the clean image. So as I show you, we have the classes. So I don't need to print that anymore. Instead, let's find the class name. So class name, 1, 2, 3, 4 spaces, class name equals od dot classes, and then we need to get the ID from here. So let's open the brackets if I find them. Okay, I found them. Classes, we need to get the class ID, class ID, and this must be index 0. Unfortunately, we use it's not so intuitive to use index 0, but class ID is inside an array, so we need to also get inside again. That's how it is. Not so intuitive, but class ID and then 0 again right here. Okay, and then close this again. I'm not sure about if I'm making everything correct. At least there are no typos, so I'm going to print class name, and then I'm going to test this to see if it's working correctly. So let's print class name, class underscore name, close, and let's now run this one. Okay, we have laptop, person, it's working, cat, mouse, person. The class name is working, so very interesting. Now we can make things more interesting by giving a different color for each object. So we have also the colors similar to the class name. We have a list of different colors, so let's give a different color for each object. Color equals cv2, no, color equal od dot colors, and then again class id. I have to copy the same from this other one. Okay, od copy, and I'm going to paste this right here and paste off. Unfortunately, it's not so easy with the phone as with the computer. Hopefully I will get this right now. Okay, paste all the colors. And now instead of, we use this color right here. I've removed colors and I use this one right here. Let's run this one. I'm not 100% sure that this would work, but if it doesn't, I know how to solve this. Okay, it does work, which is very interesting. So again, we have the color, different color. Let's also put the object name together. So over the object we put the rectangle, but also let's display what object is that one. So we 1, 2, 3, 4 spaces, cv2 dot put text. We want to put the text on emg. Then what text? Class name. Class name. Then the position of the text, we have X and Y. So we have X and then we have Y, but Y is the top left point of the rectangle. So let's give some space and let's put the text a bit above the rectangle. So instead of saying just Y, we say Y minus 5 or 10. 5 should be fine. Y minus 5. And let's close this. Then we can choose like the font, and I want to make this very quick and simple, so I put font index 0. It doesn't really matter now, the font. Size of the font, let's say 1. Color, we give the same color. And thickness of the text, we say 2. And hopefully I haven't misspelled anything. And first of all, let's reload again the image. So I'm going to load this one, reload the image, and then we perform the detection. And okay, it's very small, but we can see person, cup, mouse, book, laptop, chair. It's very interesting, the result that we are getting. Very, very interesting. So we're getting correctly almost all the people except the one on the left, which is very far and hidden. So all the rest we're getting them 100%. Now Let's, as I promised, we're going to make a program. So let's now count the objects that are here, and let's save this on a text file. So we're now going to complete the program on a new cell, or actually we can do that here. So we can say objects count. We could make this advanced. We could make this advanced to detect every specific object, but it will complicate a lot the program probably. So, okay, let's do just object count. And I'm thinking, let's make it simple. Let's calculate only a few objects. So let's calculate how many people are there, because I could do that, but it will be long, and I want to make this simple. So count specific objects. So I'm going to put a comment count specific objects. So we want to count how many people are there, and how many laptops, and how many books. This would be, I think that this would be fair. So person. So what we are doing to make the count, I'm going to put everything outside the loop. So before we perform the detection, so before we loop through all the objects, we initialize the count and we set everything to 0. So before, of course, making the detection, we don't know how many objects we have. So we don't know how many people we have before watching the picture. So person equals 0. Then what is the other? Laptop equals 0. And then book equals equals 0. Once we detect the object, so after class name, we can say if class name name equals person. So if we detect a person, then 2, 3, 4, 1, 2, 3, 4, we increase the count of persons. So person plus or equal 1. Where is the plus? Okay, plus equal 1. And the same we do for, okay, let's copy this. Let's select, okay, copy, and let's paste. So elif class name is laptop, then laptop plus equal 1. And we do this. We do the same now. We do now the same for also the book. Paste. 3, 4. Elif class name is book. Book plus equal 1. Now at the end, so we can perform this. So let's first run the first cell to reload again the image. Let's also run this one. So we perform the detection, we show everything on the screen. And now also we can show our final result. So we can display print laptop, okay, let's say person Let's see what we get for person. We get 5 if we print. And we have 1, 2, 3, 4, 5. We have 6 people, but 1 is very far and hidden, so 5 it's pretty it's fair for our detection. Print book, and we have 2 books. And then let's print laptop. Print laptop. Print a laptop. Okay. 1 laptop, which I don't see where this is. Okay, I see the laptop, which is fair because there is only 1 laptop, probably 2. And the other are stationary computers, stationary Mac, so it's a good detection. Now let's complete the program. We have the detection. Let's say everything on a text file with open. So we're going to open a new file, and we will call this file Summary.txt, and we close Summarytxt and then W, because with this we can either read the file with this function or write the file. So if we put R, it means read, to read the file. We want to write a new file, so use W, and then we close this as file object. So this is the standard Python standard to work with file objects. Then okay, I can just copy and paste this one right here, copy one, 2, 3, 4. Let's paste this right here. So first is laptop, then second is books, and then books, and then people. Okay, 1, 2, 3, 4. Then string of person, plus, and then people. And let's close this one. And our program now should be finished. So I'm going to run this cell, and we should see a text file with the summary written saved on the disk. So if I go here and I show file browser, we see summary.txt. Let's download and let's open this file. Let's download and open Summarytxt. So I have downloaded. I need to go on the downloads, Summarytxt. Okay, in this picture there are 1 laptops, 2 books, 5 people. So I forgot to put the backslash among laptops, books, and people, but you get the point. So we have the program done. If you put the backslash, it will put laptop, books, and people in different lines, and it will be organized. Of course, this was a very basic way to do things. There are better ways, but this was the simplest and fastest way that to get a program done very easily with just this phone. I hope that you enjoyed this video. Let me know in the comments what you think about this project by using the phone and what you would like to see next. This is all for this video. See you on the next one.